Now that I've talked about potential energies, I want to cover conservation of energy. If you consider a system of objects, whatever those objects are doing, however they're interacting with each other, as long as that system of objects is isolated, as long as that system is closed, the energy stays the same. So however much energy we had in the system to begin with, anytime later, we have that same amount of energy as long as that system is closed. However, mechanical energy isn't necessarily conserved. And remember, mechanical energy was all the kinetic energies and all the potential energies in our system. So those won't be conserved if there are certain forces present, and we call those forces dissipative forces. Chances are, if there's a potential energy that we are able to construct, like gravitational potential energy or elastic potential energy, the force that we're working against is a conservative one. And the way we can tell something is dissipative or if it's conservative. So conservative versus non-conservative is, does the path matter? So if we go back to that box example, if I'm pushing a box around a certain path, if I'm following this pathway, I'm fighting friction the whole time. So I actually end up doing more work to get the box from A to B. If I take this long pathway here, friction's going to find me the whole way. If instead I just go from A to B, friction's still going to fight me the entire way, but the pathway is now shorter. So the distance or the displacement that friction is working with is much shorter. So even though friction is present the whole time, the path is shorter, so I would be doing less work against it. And for those of you wondering, well, on that winding path, the friction is at different angles the whole time. Well, keep in mind the velocity, the direction that the box is moving in, is always tangent to that path. So it'll be parallel to the friction as well at any given point. So yeah, that winding path creates a longer parallel displacement or a longer parallel distance. So friction is one example of a dissipative force, a non-conservative force. And what we mean is friction is going to take that mechanical energy and convert it into something that's non-mechanical. So something that's hard to get back or hard to measure. So it could be a heat transfer. Maybe the floor warms up a little bit. So if you push like a cart across one of our tracks in class and you watch it with an infrared camera, you might notice part of the track is slightly warmer in that infrared filter. And that heat transfer would increase the internal energy in the track, and that would be considered non-mechanical in this case. What I mean by internal energy is, if you imagine this box here, we say it's one object, but that's not quite true. A box is not, according to our technical jargon, an object. It's actually a system of smaller particles making up that cardboard. And those molecules have energy, they move around. vibrating and whatnot. So if the internal energy of the box increases, those might vibrate faster, anything like that. And that would be kind of lost to us. It's hard to get that energy back. And that's what we mean by internal energy. Whenever we pick something to be an object, but inside we have other particles or other objects, they have their own energy, and that's what we're referring to as the internal energy, the particles' kinetic energy. So, if there are no dissipative forces, the total energy in the beginning, the total mechanical energy in the beginning will equal the energy at the end. If we do have dissipative forces, they're going to do work. So we can think of it like this. The kinetic energy at the beginning plus the potential energies at the beginning plus or minus any work done will give us kinetic at the end and the potential at the end. When we're determining whether the work is positive or negative, if the work being done by the force is what we say is into the system, so it's adding energy, we would use the positive. If the energy is used to do work on something else, so whatever we consider our system of objects, if that's using energy to do work on a second system, that's out of. And we would treat that work as negative. Now remember, we can think of all forms of energy as work done or against the system. So done on the system or work against the system. So we're not going to count them as work if we're already counting them as energies. We don't want to double dip.